Function pointers can be really convenient in a number of circumstances. Let's take a look at an example. Let's make a working copy of func.c, place that in our working project. And here we have just a simple function, doesn't take any parameters, doesn't return anything, and we're calling it like this. So if we compile this and run it, you see it prints out this is a function. Now, instead of calling it like this, I can create a pointer and I can call it through the pointer. I can say void func like that equals func. Now I'm reusing the name there. I don't want to do that. I'm going to call this f pointer. And then I can run it like this. And that'll actually call the function. So let's compile this and run it. And we see we have exactly the same result. So the difference here is that I've declared a pointer and I'm calling the function through the pointer. The syntax of the function pointer might look a little bit obscure. Well, it is a little bit obscure. And you'll notice that the pointer operator and the name of the function are inside of parentheses, and that's like that because of operator precedence. And then the function operator is on the outside of the parentheses. So this indicates that we have a function pointer, and we call it with exactly the same syntax. And that's true of so many other things. We dereference a pointer with exactly the same syntax that we declare a pointer with. So that's what a function pointer looks like, and that's how a function pointer works. Let's take a look at this in action, see what it might actually be useful for. We'll close this and we'll delete our working copy of func.c. I'm going to run clean because we're going to use a different source file here. And I'm going to bring in jump.c. So we'll copy that and paste it into working project and bring it up here. I'm going to walk through this in a second here. Let me just show it to the folks who might be typing along at home. Now I'm going to compile this and run it, and you'll see what it does. It basically puts up a menu. I'm going to maximize this so you can see what it does here. And if I type a 1, Eclipse is a little bit funny with this. You'll notice that the cursor is up at the top, but when I press the 1, it actually goes to after the prompt. That's just Eclipse. On a real console, this would work just fine. And I'm going to press 1, and you'll see it runs function A, which says this is A. And if I press a 3, you see it runs function C. It says this is C. If I press something out of range, if I press like a 7, it says invalid choice. And if I press Q, it will actually quit. So let's bring this back down and let's take a look at the code and see how all of this works. So we have these 5 little functions here, and then we have forward declarations for a couple of functions that we'll look at later. And then what we have here on line 13 is we have an array of function pointers. The array is called funcs, F-U-N-C-S, and you'll notice that inside that first set of parentheses, there's the asterisk, which indicates that it's a pointer. There's the variable name, which is funcs, and there's the square brackets, which means that it's declaring an array. And then we close out those parentheses and we have the function operator on the outside. And this basically says that, well, this is the way that you declare an array of function pointers. And then we initialize the array of function pointers with the addresses of these 5 functions and a null pointer to terminate the array, because this is C, it's not C++, and this is not an object vector. This is a simple C array with 5 pointers in it and a null pointer. Then main calls the function prompt, and then it says done when it's done, because prompt will turn around and call jump, which actually uses this jump table. So this structure, this array of function pointers, is sometimes called a jump table. And it can actually be really, really convenient for console-based applications that use a menu, or I've even used in CGI applications where I have a number of different possible options that depend on a variable getting passed through CGI. So there's the prompt function, which basically puts out the prompt, which is that menu and the little prompt characters there. And it gets the response using fgetLine, and it calls jump, and it returns the return value from jump. Now the jump function, this is where the work is actually done. It takes the response from the keyboard, and it decides if it's a Q or not, and if it's a Q, then it returns 0, which means that we're done. And otherwise, it uses this little for loop to get the length of the array. Line 47 is just a little trick for converting a character into an integer. The first character of the response string, it simply subtracts the value of 0 of the ASCII character 0, and then it's got an integer. It's got a 0-based integer. And it checks to make sure that it's a valid number, that less than 0 or greater than 8 is checking to make sure it's a valid number. We've decremented 1 because our number 1 is going to be the 0th element of our array. And then down here, starting at line 54, we check to see if we're in range, if we have that many elements in our array, and if so, we go ahead and call the function. And on line 55 there, it's calling the function from the array. So we have I as the index into the array, and the function operator at the end, the parentheses, tells it to call the function based on that pointer. So this is a really, really simple way to implement a menu in a console-based application, or to implement any kind of a jump table where you might want to be calling different functions based on a piece of data. Now, of course, this works just as well in C++, and let's just take a quick look at this in C++. We're going to go ahead and delete our working copy of jump.c, and we'll run clean. And we'll make a working copy of jump.cpp and paste it here into our working directory, and open it up, and we'll run it. And you see here, this works exactly the same. If I type 1, I get, this is A, 2, this is B, 5, this is E. If I type 6, I get invalid choice. If I type a Q, it quits. So this works exactly the same. It's mostly the same code. You'll see our functions look exactly the same. Instead of our jump table in an array, we're actually using an STL vector here. And we'll cover this in the chapter on STL. But basically, that's how you declare a vector. And the type is a pointer to a void function. So that's the type that goes in the template for the vector. And we just have the 5 here because this is a vector and it knows how long it is. We don't need that terminator. The prompt is pretty much the same. We're using cout instead of printf because this is really convenient to be able to do cout like that, all in one statement with one semicolon. And our string response cin, this is actually all a whole lot simpler than it is in C. And our jump function is almost exactly the same. You notice we're able to test against the size of the vector using the size method out of the vector, so we don't have to figure out how long it is. And we're calling it exactly the same way that we would call it out of the array. So that's how you create a jump table using an STL container in C++. So function pointers can be really useful. You're not going to need them often, but when you do, it's really convenient to know how to use them. Now let's delete our working file and run clean to get set up for the next lesson.